video, we're going to talk about graphing inequalities on a number line and compound inequalities. So this first slide, I'd say you don't really need to write anything down. Just review that if you have greater than or less than, it's an open circle or parentheses. And if it's less than or equal to or greater than or equal to, you'd want to have a closed circle or a bracket. And when you're solving inequalities, if you divide or multiply by a negative number, you must flip the inequality symbol. So here's vocabulary for you. A compound statement is made up of more than one equation or inequality. In this case, a disjunction is a compound statement that uses the word or. So if you could just go ahead and highlight the word or here in your notes. And it means disjunction. And here's an example for you of a disjunction, where we have a number line and we have two pieces. We have this part of the inequality that's graphed out and then this part here. How you read this is x is less than or equal to negative 3 or x is greater than 2. So here's an example of a compound inequality. We have two pieces. We have x plus 3 less than 2 or 3x greater than 9. And we want to first solve those inequalities separately and then graph them on a number line together. So in this first piece, we want to subtract 3 from both sides. So we get x less than, and now 2 minus 3 is negative 1. Or, on this side, I want to divide both sides by 3, and I'm left with x greater than 3. Now we go over and graph these on a number line. So we'll take care of, I'll put this one in red. It's an open circle, and it says x is less than negative 1. So less means we go to the left. Now this second one I'll have in green. We go over to 3, again open circle, and now it's saying x is greater than 3. And that's how you would graph this compound inequality that is a disjunction. The second vocabulary word is conjunction. And it uses the word and. And here's an example. We have negative 3, including all the way over to a little bit less than 2. So how you say this is x is greater than or equal to negative 3, and x is less than 2. A conjunction is true if and only if all parts are true. So you can convert this compound inequality into one inequality that looks like this. And then here's an example of a compound inequality. Just like the example we did before, we want to solve them both for x. So let's take the first inequality of negative 2x is less than 8, and let's solve it for x. So we'll divide both sides by negative 8. Now remember, when you divide by a negative number in an inequality, it's going to flip that inequality direction. Now I'm left with x on the left, and then 8 divided by negative 2 is negative 4. And then I have the word and. Let's come over to the second inequality. I want to add 3 to both sides. So I'm left with x less than, and then 2 plus 3 is 5. Now let's graph this compound inequality. So we'll start with x greater than negative 4. So it is an open circle greater than. Now, this second one, x is less than 5. So it's an open circle, and less means it's going to the left. So notice these two inequalities come together. This is called a conjunction. You could also rewrite it as this. Negative 4 and 5. I always write the smaller number first. And then x goes in the middle. And now it's x is greater than -4 and less than 5.